Hey folks, Dr. Phil here. This is going to be a quick video on identifying cost behavior and cost volume profit analysis. So with no further ado, let's jump right into it. So the first thing we'll talk about is cost behavior. It may sound like a little bit of a strange term. It's a lot easier than it sounds. So what do managers use cost volume profit analysis for? So what you see here is this is not an exhaustive list. These are just some things that they might use it for. For example, how many units must we sell to break even? What sales volume is needed to earn a target income? How much will income change if we buy a new machine to reduce labor costs? What's the change in income if selling prices go down and sales volume also goes up? How will income change if we change the sales mix of our products or services? So here's a graph. This graph is showing you fixed costs. What it's trying to kind of convey here is that if you think about where this line is, right? This line is parallel to the x-axis, right? Which is volume. So what they're really saying is as volume increases, right, the cost does not change. And you notice even at zero, you still have this cost. So one example of this type of cost is fixed cost might be the rent, right? Does the landlord care if you produce? No. You've still got to pay the rent. So imagine this was like 5 grand. Even if you produce nothing, you still got to pay the rent. Up to a certain point, obviously you're going to outgrow the factory at some point, but within what we call the relevant range, this cost will not change. Now, variable costs, on the other hand, are exactly what they sound like. They vary. Now, what do they vary by? They change in proportion to production. Okay, so as you produce more, obviously, you think about it, and it makes sense, right? If you produce more, you need more materials, you need more labor, so on and so forth. Now, this graph does start at zero because if you produce nothing, then you have no variable costs. You would not need any materials, and you wouldn't need any people on the assembly line, those direct labor folks. We also note that unit variable costs stay the same as volume changes. So think about like the variable cost per unit is actually going to be quote unquote fixed, but only up to a certain point. Again, all these things in the long run end up being variable. So here's a graph showing the fixed and the variable cost. So this is, if you look at the top graph, this is kind of what you can see from the last two slides if we were to put those together. So you can see we've got the fixed cost here of 32,000, right? So you can see this red, orangey kind of line here. We'll just say red, right above the 30,000. Again, as the volume increases or decreases on the x-axis, this does not change, right? Now, what you notice is the variable cost, that's the green line here, this increases based on what? Based on the variable cost per unit increasing as a result of production, right? So if you put, so they kind of, this is where they, if you look at the orange line here, that was the one that we saw on the last slide, pretty much right here. What they're doing now is they're taking this orange line and they're basically saying, well, let's kind of add it onto the fixed cost because our total cost, which will be fixed and variable, would be our fixed cost of 32 plus whatever our variable cost is. In this case, it's $20 per unit. So if we produce nothing, we still have to pay these fixed costs of 32,000, right? Again, think like the landlord doesn't care whether you're producing, they just want their rent check, right? And then if we look at the graph below, the relation of per unit fixed costs and per unit variable costs based on volume. So what you notice is these costs, both of these costs come down, right? Total cost per unit and fixed cost per unit, they do decrease, but they end up being what we call asymptotic. They will never actually touch the x-axis, obviously. They will approach it, but they will never actually touch it. And then we have what we call mixed cost. So mixed cost is what it sounds like. It's mixed between, it has a variable and a fixed component. Okay, so mixed costs are going to be greater than zero when volume is zero because, think about why, because you have a fixed component and then it'll increase steadily in proportion to increases in volume, which represents the variable component. So a good example of a mixed cost would be, let's say you went for a job interview for like a sales position and they said you get base, like a base salary, that would be the fixed part, plus commission, which would be the variable part. We also have what we call stepwise costs, and you can probably look at the graph and determine why they're called stepwise costs, because in this case they increase in steps or increments of 10,000, right? So up to 1,800 units in volume, the cost is 10,000. If you go above 1,800, it suddenly jumps to 20, and then this is of course another 1,800, 18 to 36. then it goes up again. So it's just increasing in steps or increments, in this case of 10,000. So we call this type of cost a stepwise cost. So here we see just some quick examples of these costs. Now I won't go through every single one, but just this would be a good place to pause, look at these, and think to yourself, okay, do I understand why all these are fixed, all these are variable, all these are mixed, and all these are stepwise, right? So, for example, fixed costs, we talked about rent. Again, the landlord doesn't care if you produce or not. It's not related to production. You got to pay the rent regardless. Now, the variable costs are going to vary based on production, so things like more materials, more labor. And then we have, remember, the mixed costs are a mixture of fixed and variable. So again, that's the example I was just giving you, right? Sales rep is salary plus commission. Something like natural gas, maybe you have to pay a certain amount, like a fixed fee, and then everything above a certain usage may be charged at a rate, which would be concomitant to a variable cost. Stepwise costs, again, adding or dropping a shift of workers. So let's say that you add a shift of workers, and to run the shift is going to cost you, say, 10,000. Again, every shift you add, you sort of increase it in steps of 10,000. So let's talk a little bit now about measuring cost behavior. So there's different ways we can do this. There's some more simple, there's some more complicated. The three that we would typically use in sort of a cost managerial type setting would be this. We could use a scatter diagram. It's very kind of basic. High-low method, which is the one that we'll focus on here in this video. Regression, which is something that you'll kind of be exposed to in a business curriculum, certainly in an MBA, like a grad program, you will certainly should be running regressions. You can think of regressions as a sort of stochastic, like a forecasting type tool. So what we have below us, or below us, excuse me, below this table here is we have all the months of the year, right? We have units produced, and then we have the total cost. So keep that in mind, because we're going to need some of that information in order to determine these three types of forecasting tools, if you will. So the first one is a scatter diagram. So all they've taken for the scatter diagram, all these green points you see, they're just plotting these like January 27.5, 21.5. So that's been plotted. So all these green dots represent the months of the year, plotted based on their X and Y Cartesian coordinates, of course. So as an example, you can see March. You could go back and look, and you could go back and look here. Look at the values for March 25 and 25. So you can see, yep, 25, and about halfway between these two. So yep, 25. Now the line is basically our cost estimator. Okay, so everything that's not touching the line represents error. So we can see, like, this point, this is what actually happened in March. This is our guess. The line is our guess. So you can see there's quite a big error here, right? This one, not so much. This is almost on the line. Anytime it's pretty much on the line, there's almost no error. The further away these points are from the line, then the more error there is. So let's talk a little bit about the high-low method. And you're going to see exactly why it's called that in a second. So the following relationships between units produced and total cost are observed. So this is all the information that we just looked at before. We've got our months of the year, units produced, and total cost. So in order to work out this method of doing things, then all we need is just 2 points. We need the highest and the lowest volume levels. Okay, so the formula we use, and the formula that you would always use, is cost at the highest volume minus cost at the lowest volume. So we can see that if we look here, units produced, this is the lowest one, and then we have the highest volume, which is 67.5. Okay, so you can see where they're plugged in. You can do this either way around. I always do the volume first and then the cost. That's just my preference. You can do it the other way around if you want. So highest volume, you can see here 67.5. You can see where I plug that in. Lowest volume 17.5. And then for the highest cost and the lowest cost, we can see 31,000 and 18.5. We plug those in. So think of this as kind of like your rise over run, right? If you remember the slope line intercept, y equals mx plus b stuff, it's basically, this is kind of the slope part of that anyway. Determining the gradient, right? Determining that m, the slope from linear algebra. So we get 12,500 over 50,000, and we get 0.25 per unit. Then what we do is we just plug it in to determine, and here you can plug in the 0.25 to either the high or the low. It doesn't really matter which. So if you notice, like on both sides, these formulas are the same. Total cost equals fixed cost plus variable cost per unit times the units. So in this case, I'm using the highest, 31,000 equals the fixed cost plus, and now look what I'm doing. I know that my variable cost per unit is 0.25. I just calculated that, times 67,500 units. Okay, so think about the 31,000, the 67.5. So I'm just plugging in my numbers, and then I'm basically saying below this that 31,000 equals the fixed cost plus 16,875. 16,875 is just from above, 0.25 per unit times 67.5. So what I'm able to do here is I'm able to determine how much of the cost, like in this case, the 67.5, the total cost, excuse me, I'm sorry, the 31,000 total cost, how much of it is variable and how much of it is fixed. So I'm able to determine that 14,125 is fixed. Now, if you want to check yourself, you can actually do this again. And this time, if you look here, they use the lowest cost, right? The 18.5. But if you notice, if you work your way through, you'll get the same number. So that might be a good idea the first couple of times you do this as a way to like check yourself to make sure that the fixed costs both come out the same. They're fixed, right? So they should both come out the same. So our total cost equation in this example, based on these numbers, equals 14,125 fixed plus 0.25 per unit produced the variable. Okay, next thing, contribution margin. So the contribution margin, very simple, just equals the selling price per unit minus the variable cost per unit. That's it. So selling price minus variable cost equals the contribution margin. Now we also talk about the contribution margin ratio. So how do we calculate that? We just take the contribution margin per unit, or just contribution margin, depending on if you're looking at per unit or if you're looking at just total, like overall amount, and then divide it by the selling price per unit. So CM divided by sales, right? Or per unit. And you can do it on a per unit basis, so you can do it on a dollar amount basis. Either way is fine. So by way of a kind of a quick example here, we can see selling price per unit is $100. Variable cost per unit is 70, so we have a CM, contribution margin per unit, of 30. The contribution margin, basically, the reason it's called that is because it's like, what do I have left over after variable costs to contribute to covering my fixed costs? And then once they're covered, then going toward operating income. So contribution margin ratio here is just 30 divided back into the 100. So of course it is 30%. All right, so the next thing we'll look at is break-even point for a single product company. I'm sure you've all heard of break-even point. Think of it as where total sales equal total costs and there is no income. You're not losing money, you're not making any money, you're just at that point. You're at zero, right? Like -1 onwards is negative, +1 onwards is positive. You're right there in the middle. Now you can state this in terms of sales dollars, you can do it in terms of units. And there are really three methods that we use to do this. We'll use the formula method. We can do a contribution margin income statement, or we can do what we call a CVP chart. All are good in different ways. I would say that the formula method is the quickest, kind of the quick and dirty way of doing it, and probably more accurate than doing it by a chart. Contribution margin income statement might be a good idea to do after the formula if you wish to check yourself the first few times you do it. So just so you can see how easy this is the formula method I was just talking about. Break-even point in units, we just take the fixed costs, 24,000, and then just divide it by the contribution margin per unit. In this case, it's 30. These numbers are just given to you. So what we're saying here is we'd have to sell 800 units in order to break even. If we're trying to get the break-even point in dollars, then now we're just going to take the same fixed cost, 24 grand, divide it by the contribution margin ratio. In this case, 0.3. So 24,000 divided by 0.3 is going to give us 80,000 sales. So we're really kind of saying the same thing in two different ways here. We're saying that if you want to break even, you got to sell 80 grand's worth of stuff. You would do that by selling 800 units. Okay, this is the contribution margin income statement method. So this is kind of the one I was saying you could do thereafter to like check yourself. So if we plug in the numbers, first, let's just real quickly look at the format, right? So contribution margin income statement format, you always start with sales. Then you take out all of your variable costs, which gives you contribution margin. You then subtract your fixed costs, which gives you income. So in this example, right, so we have sales, 800 units at $100 a piece. So the sales revenue was 80 grand. The variable costs were 800 units at 70 each, which is 56,000. If we subtract the 56 from the 80, we get 24,000. And we had fixed costs of 24,000. So thus our income is zero. So what we've just done is we've just proved that our two numbers are correct. 800 units, 80,000's worth of sales based on 24,000 fixed costs. And then this is the cost volume profit chart. To be honest, I wouldn't worry too much about this one. I would do it this way, the formula method first. If you want to do it just to kind of check yourself by following up with the income statement method, that's fine. And then the CVP chart is really just a good graphic, kind of showing you here, right, that, as you start to produce and as you produce more and more, the loss area gets smaller and smaller. Eventually you hit your break even, right? Just as we said, $80,000 or 800, I should say, or 800 units. And then you have, as you move past your break even, that obviously it gets wider because you're making more and more profit at that point. Now, what if estimates change? Obviously, in business that can happen, right? So, like, if you look at there's some things that we could change here, right? We've got selling price per unit, variable cost per unit, CM, contribution margin per unit, total fixed costs, and break even in units. So we've got most likely for each, and we have pessimistic. So what if we were to revise these and use the pessimistic numbers instead? So the pessimistic is saying that the selling price is going to be lower, right? 100, now it's 96. Variable cost per unit is a little higher at 72. So 96 minus 72 is going to give us your CM per unit of 24. You can see where I plugged that in down there. And then our fixed costs are about 3,000 higher than the original scenario. So 27,000 fixed cost divided by 24. So in this scenario, we'd have to sell 1,125 units. So basically, if we increase expenses, if we increase our fixed costs, we also increase our variable cost just slightly by $2 per unit. So think about it. It kind of makes sense, right? If you increase your expenses, if you increase your costs, you're going to have less of a margin on each one you produce and sell. So you're going to have to sell more in order to hit your break-even point. If you remember before, it was 800 units. By making these changes, it's now increased to 1125. Okay, margin of safety, next thing up. So margin of safety, very simple, kind of is a logical kind of corollary to break even. Think of margin of safety as like how high above the break even point are you? So in this sense, you could also maybe postulate that the higher the better, right? So margin of safety in percentage, we just simply take the expected sales, subtract the break even sales, and then just divide it again by the expected sales. So you can see 100,000 expected minus 80,000 break even divided by 100,000 is going to give you your 20%. Or you could have just probably eyeballed that and said, right, well, if break even sales are 80,000, expected sales are 100, we're 20,000 above that. So obviously that would equal a quotient of 20%. All right, computing income from expected sales and costs. So this is, again, just an example, a little kind of demonstration here of using the contribution margin income statement to determine revenue, right? Sales, 1,500 units at $100 each, 150,000. Your variable cost, again, 1,500 units. Your sales units and your variable cost units should always be the same. In this case, the variable cost was 70 each for 105. Your contribution margin is 150 minus the 105 to give us the 45. Take out the fixed costs of 24, and we would have income of operating income of 21,000. All right, what about computing sales for a target income? So just FYI here real quick, if you go back and look at the formula for break-even sales in units, it was basically fixed cost over CM. Notice here that the only real difference is they kind of kept the formula the same, but now we're dealing with target income. They just added the target income to the numerator. So it's like saying, well, we now want to cover our fixed costs, and on top of that, plus our whatever our income is we want to make. In this case, the fixed cost for 24, as we know, they want to make a target income of 12,000. So they just took the 24, they added it to the 12, and then they took the CM, what we call the CMR, contribution margin ratio, which is 30%. And so think of this as 36,000, 24 plus the 12, divided by 0.3 gives us 120,000. So what they're really saying here is, in sort of layman's terms, if you sell 120,000 worth of stuff, you will be able to pay your variable costs, obviously. You'll be able to pay your fixed cost of 24, and you'll be able to achieve a target income of 12,000. So what about computing sales for a target income in units? So the only thing we're doing differently here is if we go back and look at the formula, 24,000 plus 12, this was for target income in dollars we just looked at. As I go back and forth, the only difference is what is the contribution margin per unit. In this case, the contribution margin per unit is 30. So what they're saying is you would have to sell 1,200 units. And again, they're kind of saying the same thing here, right? If you sell 1,200 units, you would make $120,000. All right, and here is a contribution margin income statement. Well, what we start with in step one is part of one, and then the idea is you kind of like working your way backwards. So let me explain. So let's say that you had a problem, right? And all they gave you were fixed costs, 24,000, and then target income of 12. So the first thing we could do is we could add the target income to 12 to the fixed cost of 24. That would give us our contribution margin, which was 36,000. And then we know that the relationship from sales to contribution margin was 0.3. So we would just we're kind of working backwards. So instead of multiplying by 0.3, we'll divide 36,000 by 0.3 to give us the 120,000. And then you could figure out if you took 120 minus the 36, the 84,000 would be kind of the plug number, if you will, which would represent the other 70%, right? The variable costs. Okay, sales mix and break even. So we can modify the CVP formulas for when a company sells more than one product, which of course is more realistic. So the unit contribution margin is replaced with weighted average contribution margin per unit. So sales mix is the proportion of sales volume for each product. So as an example, again, they always, whenever you read something like this, it always makes it sound way more difficult, as you will see, than it really is. So we have two products, footballs and basketballs. So we have the sales price for each, we have the variable cost per unit for each, and we have the contribution margin per unit for each. So we have a sales mix percentage of 60% and 40%. So they gave you those. Don't worry about trying to get those from those numbers. They gave you the 60% and the 40%. So the formula we would use is weighted average contribution margin per unit is the CM per unit for each product times the sales mix percent for each product. So what we're doing is think about order of operations. We're saying CM of 30 times 60% plus the CM for basketballs 35 times 40%, and our weighted average is $32 CM per unit. Okay. Now, what about weighted average break even in unit sales? Well, we now know that our weighted average contribution margin per unit is 32, right? So all we have to do is we just take our fixed costs, in this example of 48,000, and we just divide by 32, and we have to sell 1,500 units, right? Now, it's about to be explained in the table below, but you might be looking at that 1,500 units and saying, okay, well, they're selling two different things, so, I need to know how much of each to sell. And hey presto, we're going to sell 1,500 times 60%, so we're going to sell 900 footballs, and then 1,500 times 40%, 600 basketballs. Okay, last thing, and then we are done for this video. Analyze changes in sales using the degree of what we call the degree of operating leverage. So the degree of operating leverage, you can think of this as how does income change and how does sales change and how are those changes related to each other. So the formula we use for DOL, or degree of operating leverage, is contribution margin divided by income. And here is just so you can see it's not that difficult. Here is an example. So the degree of operating leverage, DOL, the contribution margin is 36,000. So you can see CM is 36,000. Our income is 12. So we have degree of operating leverage of 3. Okay, so then the change in income as far as percent goes is the DOL, which is 3, times the change in sales, which was 10%. And then we have a change in sales, change in income, of 30%. And if you notice the income, 12,000, right? Look at the sales, 120,000, right? So you can kind of see where the 10% is coming from. Okay, thanks as always, and I will talk to you guys soon. Take care.